While waiting for Lars Gustafsson from Caliterra to talk about the GNSS, Global Navigation Satellite System. Marcus, I know that you've been thinking some about this GNSS. What kind of reflections do you have?
Well, my first reflections is when I started to learn navigation 100 years ago. I was on a sailing ship, and we had this Deccan navigator system in the wardroom, and the captain put a blanket over it, so we needed to use sextant and dead reckoning and so on to find out where we were. And once in a while, he checked our dead reckoning with the Deccan navigator system, but we didn't get to use it. So I'm taught in the old system.
Good for us, at least, to be part of your 100th anniversary. That's interesting. Thank you for sharing that day with us.
Yeah, thank you. You're welcome. But nowadays, I mean, everybody can navigate today, at least through a mobile phone even, or whatever. Satellites are a really good tool for this, so soon to be the only tool, I would say. My knowledge of navigation would be obsolete, since it's not taught anymore. But there are questions with satellites as well. In my view, they need to be replaced. Are there a program for replacing them or even expand to get newer satellites? It probably is. And I also know that satellites are getting smaller, more capable and cheaper and so on all the time. So I would be very interested to hear about this, because I think you are going to talk about the technology behind why we are where we are with the ship and how to find out that. Thank you.
Mm-hmm. So give Lars a big hand, and we will look forward to the latest news from 20,000 kilometers above.
Thank you. Yes, I am Lars Gustafsson from a company called Caliterra. It's a company within a larger group of company, still a small group, but it's a company group that makes GNSS hardware and software and firmware. So we make all the components of the positioning system. Oops, I've been a little bit bored. So we are family owned. We are a family company, which is very unusual in this case, because normally you would have companies funded by national or military funds. But we are totally independent and family owned. Our competitors are, for instance, companies like Trimble, Leica, Topcon, Hemisphere, which is maybe known here. They have quite a number of marine products. What is our core technology is GNSS, so global positioning. And we work worldwide on both large and small projects. These are an example of two projects where we work that are big, that we work on. This is we are delivering GNSS positioning system to the US Department of Defense for their surveying equipment. This is a, see if this works now for me. Yeah, this is a military standard unit with GNSS board inside and an antenna for satellite monitoring. and this is actually a base, what we call a base rover set, which is you have a steady station here and a moving station over here. This is all based on requirements from the US Department of Defense, and it's mainly used for mapping, so it's mainly civilian applications, but for the US military. This project here is another project that we've been working on since 15 years, about. It's the land demarcation projects in Africa. This is from Uganda, and it's a project funded by the World Bank, where we are certified as GNSS providers to provide the positioning system for this land demarcation projects. And these are pilot projects for larger projects worldwide. So we have projects on land. We have been working with the Swedish Nuclear Waste Administration, SKB, to monitor their the movement on the bedrock in Forsmark, among places. We are working on projects in the naval area on sea with the Mona Lisa 2.0 project, SINAFA, and we also have our own marine surveying equipment and service. And we also work with space, with projects with NASA, ESA, and DLR. So it's a wide range of different applications that we work with. Our products, and I've taken some examples here. This one, the big unit. The big unit here is actually this big because it fits up to 4 GNSS receivers, and the GNSS receiver inside is rather small. It looks like this, and this is developed here it's manufactured here in Bräkne-Hoby and developed in Lund. So it's nearly a Blekinge product. So are also these products, of course. This is a unit that can hold up to 4 of these units internally, but it also has internal computer, internal GSM modem, radio modem as well. So it's an intelligent box to use in different environments. It can be placed in excavators, it can be placed on ships, as I will show a little bit later. We then have this type of units that can be used for traditional surveying. And also these sensor type of units that can be connected to a number of equipment to get a high accuracy position. So, as I said before, we are independently developed and we own our own GNSS technology, and we try to keep it clean and simple and use state-of-the-art components. This means that we use the latest in technology in our products, and we keep it by having smart solutions internally here. We can easily modify and adapt these sensors to be used in different applications. And we make them, of course, as reliable as well. Just to remind you of what GNSS is, because we may use GPS, we may use GNSS in different terms, and I that work with this always, of course, know what it means, but GNSS stands for Global Navigation Satellite Systems. This is before we used to say GPS, because it was the American system. Now we say GNSS because we have a number of different systems. GLONASS is the Russian system, and Galileo is the European, and Beidou is the Chinese system. And they all have, we can say that GPS and GLONASS are totally fully developed today. They have complete satellite systems of more than 30 satellites. These are traditional satellites, traditional satellite vehicles, like this one, rather big units. And I will show you a little bit later what we are also involved in terms of projects that may change the type of satellite vehicles like this. Galileo is just beginning. It's been ongoing and planned to be ready for many years now, but now finally they have started to launch real satellites to be used. But basically, we use all satellite systems that are available. This means that what happened from just about 1985, when GPS started, it was then called transit, when you had to measure at a certain time of the day to be able to get position. Today we have global coverage with a number of satellites, and it's increasing, and also not only the satellites but also the different frequencies sent out by the different satellite systems are also increasing. So we will have a large number of signals to take care of, and this is why we try to be as flexible as possible with our units. A specific project that we have been working on, we started this in 2014, is on the Stena Germanica ship that is going from Gothenburg to Kiel. We have mounted 3 antennas on the ship, and they are mounted on a specific spot, on well-defined spot on the ship. And by mounting these 3 GNSS centimeter accurate antennas, we get a total monitoring of all the movements and the behavior of the ship. So what we can monitor here is the roll, the pitch, and the heading of the ship, and we monitor it at about 10 measurements per second. So 10 times per second you have a new value for how the ship moves. And the antennas are placed so that you get a relation between the three antennas that are mounted. So you get a, oops, sorry, not used to this. So we get the relation with vectors from them, and these are defined between themselves on the ship with centimeter accuracy all the time, even though you are in high seas. So this is like a local GNSS network that you can work with. This means that we can, anywhere in the world, actually monitor the movement of the ship, bending and the rolling and everything. And this is just how we calculate the distance, of course. All the different parts of the ship can be monitored. Basically, this is to the center of the ship by using the antennas. So by having this system on board, you can really monitor everything. And of course, you can also monitor the track itself. When you are in high seas, the ship itself will not be, because with a GNSS equipment you need to have some kind of reference to the real world. It needs to be corrected to a system on land. When you are at high seas, you will use, there are certain satellite-based corrections. It's called EGNOS and WAS. It's used by the airplanes, among others. And there you have meter accuracy in high seas. When you get closer to shore, in densely trafficked areas, you would use the differential GPS solutions that are available today in the Baltic, for instance. So you will get half-meter accuracy on your positioning of the boat, but still centimeter accuracy on how the boat moves. And in harbors, there you get high accuracy, centimeter level positioning of the whole ship, because you have land virtual reference networks and so on that work on land. So this is using different types of corrections to supply your ship with the most accurate positioning. So what do we really get? We can use this to get the ship's attitude during cargo loading and at sea. Precise navigation in harbors to be used for docking and maneuvers. And we get the heave, the roll, the pitch, yaw, and precise heading over ground. And this is all calculated with the 3 antennas that you have on board. And this can, of course, be used for safety monitoring, for documentation of where you have been, for combining with alert systems that we heard about earlier, and to optimize fuel consumption. The Stena Monica, for instance, is leveled so that she sits 4 degrees on the front of the ship, where you can. So actually, she would be. She has better fuel economy in that way. And of course, also monitoring hull fatigue, meaning you can actually foresee that you have fissures and so on the hull by using this type of system. How GNSS and what we call RTK, real-time kinematic measurements, really works is that today we have the satellites provided by these different suppliers like GPS, GLONASS, and Beidou and Galileo. We have the need of some sort of correction, and this can be so this means that the ship needs to be connected somehow, either to satellites or to an internet network, which is available in all of the Baltic, for instance. By using the NMT system, you can basically have communication all over the Baltic. So we use the EGNOS and VAS for open sea corrections, and the DGNSS and the network RTK is the land-based systems that are available today on land. And this gives, of course, the different levels. But this is how it works. So we actually get in corrections, and we calculate with the RTK engine, we calculate the position of the ship, and we also make the calculations between the units. Talking about accuracy, this is a small project that we made, an example that we made. We put up a station, a base station, we call it, reference station here, to relate to this unit here, which you nearly don't see, but there is an antenna there on the small toy train. You see it there, and actually there is the receiver itself, and we let it go on the track around for a couple of rounds, and then we calculate this solution 3 different ways. So the standard way of calculating it is in absolute measurement in what we call standalone. Normal it's what you would normally get with a normal GNSS receiver, like the one you have available in the market. And you see it's very well placed here, but it's totally wrong in terms of reality, because this is reality. So it's misplaced just because it doesn't have that reference to that is needed. Second solution is code phase, differential GPS. This is what you usually have on your ships. I'm there again. I'm sorry. Well. You see that it's moving here. You can see that because all these stars here is one position, right? So it's one calculation of position. And you see that it's moving, but it's not. You cannot define where you are. You cannot see the movement. You cannot define really where you are. On the other hand, if you do carrier phase high precision centimeter measurement, this is what you get. And you actually get all these measurements centered on the track itself. And you can see where it is. So this is the difference. Now for positioning on water and under water, we can see that what we would like to do is to make a smart GNSS antenna buoy floating on the surface, and this can be used. These antennas are already made to be fully IP67 proof. But what we need to do is to make a buoy with this unit on board, and to either communicate with it, and it could be a submarine, it could be any type of system where we have communication either with a modem link or a wire to the buoy. Because what we can use is, we remember one of the first slides where the large satellite vehicle. What we can do today, and where we are also involved in projects, is to make satellite cluster systems, where you can have smaller satellites acting as slave satellites to the existing systems today. That also increases the number of signals, of course, available, and this can also be used as pseudolights. A pseudolight is really a land-based or a sea-based satellite. So these units on the sea surface work as satellite systems as well, and providing you with positioning to the ship. And this means that we could use for subsurface positioning, of course, sound, sonar waves, or electromagnetic waves to actually communicate between these units on the surface and the unit beneath the surface. All these projects that we have our heart system. The heart of the whole system is our GNSS receiver. And what this is a new type of receiver, which is an open source receiver. This means that you can separate your hardware and your firmware, so that you can actually use an open source firmware to use in the hardware itself. And we are the only ones that are able to provide you with this type of equipment. That means that you can actually define your product as you want and model it as you want. And this is entirely new. This is just came out in October on the market. It's also the smallest GNSS receiver for high precision available. And this is just to show you that this is available. And this is what we use in all our GNSS equipment. That was about all I had, but I don't know how I'm in time. Is it okay? Time for questions, I guess.
You were excellent in the timing. A big applaud, thank you. Lars, do we have any questions from the audience?
Oh, good.
Okay, we'll start here.
Yeah, thank you for this nice presentation. Stefan Gibis, dear Anders Strelitz. I have a question to the reliability. You show this nice graphics about the accuracy, but how reliable are these informations?
We usually, the reliability was a problem before. With all these new satellite systems and all these different signals that are available today, we increase the reliability as well, because the more signals you have, the better reliability you have. So it has increased a lot and is reliable today, I would say, by using all the different systems. This is what the advantage is, and more is coming.
Okay, thank you. Another question from Stena.
Well, thank you for a very good and interesting presentation. When you said that maneuvering in port, you have centimeter accuracy on the measurement. Is that just from the satellites, or do you have to have some more positions in the port?
Yes. We can. What we do normally is we combine in different projects. We combine with IMUs as well and different sensors, of course. We work a lot with that. But in this case, it's based only on the satellite system. Yes, because you have all the information from there. So in this case, we used only the GNSS information.
All right. Marcus, you have a quick reflection?
Just a quick reflection. I was thinking of aircrafts when they go down unintentionally. There is this black box. I wonder if this technique could be used on ships as well for accident investigation. If you combine it with other data from the ship, you can see why a ship has been lost in bad weather or damaged according to the weather.
Absolutely, and there's been projects as well where the will was to develop such a black box. So that's definitely going to happen, I think.
Okay. Thank you. Small gift.
Thank you.
Maybe you're familiar with these Karlskrona things. Very good.